Hello everyone, today we're going to look at usaco-training runaround numbers. Okay, so in this problem, a runaround number is defined as a number, an integer number, with unique digits, which means that it may not have two digits that are the same, such that if it has like two ones or two twos, and then none of the digits can be zero. Okay. And then they also have a property that is defined over here. So we can start or restart at the first digit. So for this example, we start in 8. And then we count the number's digits to the right. And then we just wrap around when none are available. Okay. So from 8, you would move 8 digits. So then it would be 1, 3, 6, 2, 8, 1, 6, 4. So it would be 1, 3, 6, 2, 8, 1, 3, 6. So then you know that 6 is the next number. Okay, so now you repeat this cycle. So then you would start off at 2, so you would be 1, 2, 3, 4, 5, 6. So your next one would be 2. Okay, so you would repeat this again, and then you would do 8, 1, and then your last digit would be 1. So then your current number would be 1, and then you would do 3. Okay. And then you do this one more time, so then you'd be 6, 3, 8. And then since you're back to your original number, and then you didn't touch a digit multiple times, this is like a runaround number. Okay, so we just have to find the next runaround number higher than m. Okay, so here we go. So what is this? It's 8 1 3 6 2. You know that this is a runaround number, so we can actually make a function or something to define if a number's a runaround number or not. So what we can do first is that let's call this a function, so like runaround. So this should take in, let's just say, a number x. Okay, so first thing we're going to have to check is to check if it has digits with or if it has a 0 in it or something. So basically, if there's a 0, if basically 0 in x, then you can just return false. Okay. So now basically we just we extract each character of that number. And then if that character is if it has already been appeared before, meaning that it has duplicate digits, then basically just check if there's duplicate digits, so duplicate digits. Then again, you would just return false. Okay. So now we know that we have to try to simulate the runaround process. Okay. So let's have a number, let's call it current. So this should be representing, for example, here's our number. It actually is blue, so 8 1 3 6 2. Okay. So you know that this is the index 0 1 2 3 4. Okay. So originally, since you would want to start at the first digit, then you'd start at 0. Oops. Okay, so you would start at 0. Okay. So now we're going to try to simulate the process. Okay, so then first we want to loop through the digits exactly n times, where n is the size of the number of digits in that number. Okay. So what we can do is that let's just say for I in range. So basically in range 5, since there's 5 digits. So basically in range 5. Okay. So now we're going to try to move current since we're going to try to like simulate this. Okay, so let's just say, for example, for A, so we have position 0, or it's actually current goes to 0. Okay, so current is equal to 0, meaning that it is at position 0. And then we're going to try to find the 8th number since that's going to be our next digit. So then let's just call this increment. This would be 8. Okay. So what we want would be we would want to get 6 because 6 will be the next number after 8. So then what we can do is that we know that the number of digits is 5. So basically we know that n equals 5. Okay. And since basically it repeats, let's just say we reach the end, we would want to like repeat starting from the beginning. We can actually use mod to get the index in O1. So then our next cur, let's call this next cur, would be equal to your cur plus your increment modded by your n. For this example, you would have 0 plus 8 divided by 5, which would get you, modded by 5, my bad. Modded by 5, which would get you 3, which is the position of your next one. Okay, so now we know that our n cur is equal to cur plus basically the digit. Let's call this d of cur. And for this example, d of 0 would be equal to 8, d of 1 would be equal to 1, d of 2 would be equal to 3, and so on. And then you would just mod this by n. Okay. So basically, we have to check that since we only can like touch each digit once, basically, you know that this is our next one. So actually before like switching your current to your next one for the next iteration, you should first check if, or you should actually first mark your current as true or something. Okay, so I'll explain this. Okay, so originally you know that you haven't used any of the 5 digits here. So then we should actually have let's just say an array. So basically CNT of I would store the number of the number the number of times I was used. So originally everything would be equal to 0, so it would be equal to nothing. And then let's just say right now we know that our current is 0 since we always start here. So we should actually mark our CNT of current, which is like increment. Okay. So now we know that this is our next current. Okay, so what if we go back to a digit that's already touched? Because if it's that case, then we know that we have to return 0 because this is, or return false because this is invalid. So basically, if there's already a count, so basically if count of current, then you know that this won't be true, so you just return false. Okay. So now, basically, you know that this would like simulate the process, but you have to make sure that yeah, so I'll actually go over this. Okay, so you would first start at 8, then you would go to 6. Okay, so let me just write down the number. 8, 1, 3, 6, 2. Okay, from 6 you would go to 1, 2, 3, 4, 5, 6. 2, 1, 2, 1, 3, 8. But actually in the last process where you go to 8, you actually find that 8 has already been counted. So then you actually mark that you actually like shouldn't return false since this is like a valid since they're going back to your beginning. So what we can do here is that we can actually modify this if statement. So if this, and then we have to make sure that this actually should be next cur. Okay. So basically, if we go back to 0, then your next cur be equal to 0. So basically, you have to make sure that your next cur is not equal to 0. Then you would return 0 or return false. Okay. Otherwise, you would just set your current to your next current. Okay, so now we basically know how to find if a number is a runaround number or not. So then, when we're given m, we just loop through. Basically, we try to like brute force it. We start from m plus 1 and we go on and on until we find our first runaround number. Whoops. Okay, first runaround number, and then we just print it out. Okay, so this problem is runaround numbers. Okay. Okay, so let's include bits. Okay. So we're going to read in a number m, and it says that it would be fitting in a unsigned long integer. So we can do just we can use some kind of like type definitions. Okay, so we're given n, so we can declare m, and let's read m. Okay. Okay, so basically for let's call this m. Okay, or you can loop through until this would work. So you could do, whoops. Okay, so you first increment your m. So you do while. Let's make our basically a while. While it's not a run around, so while not run around m, you would just increment it, and then you would just print m in the end. Okay, so now we need to make our function. Let's call this bool. Actually, I spelled this wrong. Bool. Run around. We're given a number m. Okay, so we should actually extract the digits first. So what we can do is that we can have we can like modify or like modify 10 to get the last digit, and then we can reverse the result. So we can have a vector int. Let's call this digit as in d. So then there you go, and then basically while your m is greater than 0, then you would just push back m mod 10. Whoops. And then you would just divide it by 10. And this is just to extract the digits. Okay, so now we actually have it in exactly the reverse order. So then we just reverse d.begin, d.end. Okay. Okay, so first thing we need to do is that we need to check if there's zeros. Okay, so we can go for int I equals 0, I has to be less. Okay, less than yeah. So we actually have to define n. So and this would be the size or the number of digits. Okay, and every time you would increment it, basically if d of I is equal to 0, then you just return false. Okay. Okay, so now we need to check if there's duplicates. Okay, so again, you would loop through all the characters. Okay, so let's have a vector int. This should be, let's call this count. So this should be count. So count just should have, since there's only 10 digits, this should be 10. So if there's already a count of d of I, then you know that there's a duplicate, so just return false. Otherwise, you just increment your count. Okay. So now we need to perform like the runaround process. Okay. So again, remember we have our cur, and we also have our next cur. Cur, next cur. Originally, your cur would be equal to 0. Okay. So we're going to process this n times. Okay. So your n cur would be equal to your cur plus, like as written over here, so we have cur plus digit of cur mod n. Okay. So basically, we increment our cur, or increment our digit of cur. Okay, so let's actually reset our CNT. So we can do, we can actually have another CNT. So let's call this CNT2. So then you would just increment your CNT2 of this. And as I said over here, if there's, if it already existed, so CNT2 of D of next cur, and next cur is not equal to 0, since this would basically be the last case. Then you just return false, and then at the end you would just set your cur to your n cur. Okay, so at the end we just return true. Okay, so let's actually try running this. So this is usaco-training and Runaround Numbers. Okay, so let's actually run this. So gcc main.cpp. Okay, C++. Okay. So yeah, okay, so because I included the header file, it like includes a lot of libraries, so it's going to like take some time to compile. Okay, so let's just run this. Okay, so this looks correct. So let's actually redirect the input, since I did not read from the file, which is runaround. So runaround.in our stdn, and then we just read from right to runaround.out. Okay, it's actually okay. So my ID is 3. This is runaround, and my language is C++11. Okay, so wish me good luck, and I'll try submitting it. Okay. It's loading. Okay, there we go. Okay, so it looks like that is right. Okay, so if you have any questions, feel free to leave them in the comment section below. Bye.